Okay, I think we'll get started. First of all, welcome everyone, and thank you for taking your time on this Friday to join us for this very exciting webinar, which I believe is going to be extremely insightful to all of you. So just before I kick off, just a few rules. So as I mentioned, as people started joining, please just keep your video off and your sound muted unless you're a speaker. That just helps us to ensure that we don't have any buffering and things like that for this kind of large volume of people on the platform. In terms of questions, so how this is going to work is we're going to have two speakers. So what we'll do is, and I'll introduce you to them now, but after each speaker, we'll have a question session. So what I would like you to do is pop your question in the chat box. So throughout the time that they're speaking, you can raise your question. And then at the end of Bradley's presentation, we'll ask questions to Bradley and I will facilitate that. And then at the end of Nigel's presentation, I will ask his question. So that's how we'll facilitate the question and answer session. Just so you know, the session is also being recorded. So if you would like a recording of the session, please put your email in the chat box. You can either send it to me private or you can put it in the chat box in general, and I will ensure you get a copy of the recording. Okay, and if you see me looking to the side, that's just me admitting people from the waiting room, so excuse that. So yes, let's get started. I'd like to introduce our speakers to you guys. Our first speaker is Bradley Thorpe. Bradley will give us a high-level overview of the regulatory frameworks that govern waste to landfill, as well as specifically touching on the implications of these regulations on industry. Bradley is the head of technical services at Interwaste. He holds an MSc in environmental management and has 15 years of experience in the environmental management and consulting sector, with the latter 9 years thereof focused in the waste management sector during his time at Interwaste. He is passionate about waste management and strongly believes that the continuous development and evolution of the sector has a critical role to play in achieving the 2030 Sustainable Development Goals and protecting the health and well-being of all people. So thank you, Bradley, for being here, and he's going to be our first speaker. Then our second speaker is Nigel Bester. Nigel will give an overview of the various effluent treatment technologies available to treat, reuse, and recycle on site, whilst also possibly reducing disposal costs if the waste has to be disposed of. Nigel is the head of effluent treatment technology at Interwaste. He holds an MSc in mechanical engineering as well as an MSc in engineering management. He has 10 years of experience in the water and wastewater environment, spanning various sectors from mining, industrial, food and beverage, pharmaceutical, power, and petrochemical. He is focused on delivering novel solutions to various clients through a holistic capital and operational cost approach, and he believes that the evolution of the waste sector and the overall management of water within each industry has become a focal point, specifically in water-scarce countries where the premise of reduce, reuse, and recycle are key. So I'm very excited to have these two very knowledgeable speakers from Interwaste joining us today. Before I give our speakers the floor, I would like to just show you a quick video on ZebraTube so that you can also get an idea of who the hosts of this webinar are.
Are you faced with sediment buildup in dams or liquid waste streams that are difficult to dispose of? ZebraTube's engineered geotextile bags offer fast, flexible, efficient, and cost-effective dewatering solutions. Applications can include dewatering of food and beverage and industrial waste, to dredging and containment of sewage, silt, and natural resources. Small-scale projects can be dewatered using our unique, easily handled 1 to 5 ton bags. Larger projects make use of our tubular bags. In certain applications, flocculant can be added to agglomerate solids to enable efficient settling. Once dewatered, the contained material is dry enough to be easily disposed of or reused. In addition, the filtrate can be collected for reuse. Contact ZebraTube now for your custom-made solution.
Great. So that just gives you a bit of an overview of who ZebraTube is and what we do. And so then, without wasting your time any further, let's get into it. I'll give the floor to Bradley.
All right, great. Is that coming through?
Sorry, Bradley, you might just want to change your view because we're seeing your presenter view.
Sorted. All right, great. I think, firstly, thank you for the opportunity. I think Corinne's already introduced me, but I'm Bradley Thorpe. I'm head of Interwaste's technical services. And yeah, I mean, the objective from our side today is to really give a high-level overview around the development of legislation in the waste management sector, but also to then try and maybe focus our conversation or presentation around some of the prohibitions and restrictions to landfill disposal that were brought in with the promulgation of the waste classification and management regulations.
Sorry, Bradley, just before we go ahead. Oh, there we go. That's perfect. I was just seeing still presenter view. Perfect.
Okay, great. So I'm going to take a brief opportunity just to present Interwaste. We've been in operation for 32 years now, which I think is quite an achievement in the waste space. Exciting for us was the acquisition of Interwaste by Sachet Environment in March 2019. That's a French-based multinational company, and I think what that did for us is give us access to all of our European experiences, expertise, and certainly expertise and experiences around the globe that we now fit into our service offering and feed from. So we've got a national footprint, and I'll just quickly allude to that in a second. We employ about 1,800 people. We have a significant and varied fleet of vehicles and equipment to manage a host of different waste types. We're a level 3 BEE company, and I think the figure to the right of the company just shows quite how integrated one needs to be to meet the demands of, well, waste management demands of our customers in this time. Just very briefly, we've mentioned we've obviously got a national footprint. Included in that is our owned and operated waste management facilities, predominantly in Gauteng and on the Highveld, but certainly a presence with operational depots through most metropolitan centres and across the country. But with that aside, let me focus on why we're here today. And I think this is a topic that we could speak about for a full day, if not a week. But I think this is intended just to give a very high-level overview, as stated. And what we've seen in the sector from a legislative perspective is significant and continuing development in the regulatory space in the waste sector since 2013. And a lot of that regulatory development has been enabled certainly by the enactment of the Waste Act, so Act 59 of 2008. But what have we seen in the legislation that has come out since 2013? Just to highlight some main points there is obviously we're seeing increased support to the implementation of the waste management hierarchy and introduction and implementation of circular green economy thinking within the waste sector. We've also seen increased self-regulation in some of the norms and standards that are being promulgated for use. We're also seeing increased regulation around the waste management requirements that have the force of law. I think largely until the Waste Act itself and further regulation was implemented or developed, we were reliant in many respects on guideline documents to distinguish appropriate from inappropriate waste management practices. So I think certainly we've got increased certainty in law around what one needs to be do to managing their waste effectively and in accordance with the law. Also, what we're seeing is the regulators' consideration of other fiscal and self-regulatory measures to drive their policy. And certainly we're seeing a more robust sanction being implemented for non-compliance with waste management-related legislation. And I think that's also reflected in the latest draft of the National Waste Management Strategy, where compliance, enforcement, and awareness is one of the 3 pillars that drive that strategy going forward, and obviously reflect our regulators' policy direction in that regard. Just in terms of the hierarchy of legislation, I think all of the legislation that we see below finds its roots in terms of fundamental rights under the Constitution of our country, and particularly in terms of Section 24 of the Constitution. So in essence, that advocates that everyone has the right to an environment that is not harmful to their health or well-being, and also to have the environment protected through reasonable legislative and other means. So certainly all of the legislation that is promulgated thereafter gives effect to those reasonable legislative means. What we have is, as our framework environmental management legislation, is obviously the National Environmental Management Act, Act 107 of 1998. And that enabled the gazetting or bringing into effect of a host of sectoral or specific environmental management acts that deal with one or another environmental aspect, whether that's air quality, water, waste management, biodiversity, you name it. So there's a plethora of specific environmental management acts. Obviously, our focus as an industry, or a business at least, is around the National Environmental Management Waste Act itself. And again, a host of other regulations, norms and standards and guidelines that have been brought out since 2013, enabled by the Waste Act itself. And the reason I note this is just to kind of indicate or give sight to the fact that navigating legal compliance in the waste sector is becoming increasingly difficult and potentially onerous, and requires a high level of kind of dedication and sight of what developments are happening in the space to maintain legal compliance. So I'm not going to hop on any number of these listed pieces of legislation. I think what I'm going to focus on in the latter part of my presentation is what legislative implications were brought about when the waste classification and management regulations were gazetted in August of 2013. And subservient to those regulations were 2 sets of norms and standards that direct the assessment and disposal of waste to landfill. So yes, when the waste classification and management regulations were promulgated in 2013, it was a fundamental mindset change and shift away from the guideline documents that to that point had directed appropriate from inappropriate waste management practices. So some of the fundamental changes or shifts that we saw was new legal requirements to classify wastes in terms of SANS 10234, which was the locally adopted version of the GHS. We've got new legal requirements in terms of how waste needs to be assessed for landfill and then disposed of to landfill. Again, if landfill disposal is the management method applicable to any given waste. We've seen revised landfill classes and containment barriers. So that's a shift in legislation away from what we had seen in terms of a distinction of general and hazardous waste landfills to landfill classes that can accept waste based on the assessed risk to the groundwater environment under a condition of landfill disposal. So those regulations also set out maximum timeframes for the management of waste. So certainly indefinite storage of waste is a no-no, and those timeframes are prescribed now. We've seen requirements for not only the development of safety data sheets for hazardous wastes, but that those need to be readily available and proof thereof available if waste managers are to be collecting hazardous wastes. Again, the focus in terms of this presentation is obviously there was a host or plethora of landfill disposal prohibitions and restrictions that were brought in with that legislation, and I'll be touching on those as we proceed. Also importantly, we saw an increased legal obligation being placed on the generators of waste, as opposed to that obligation sitting with waste managers. So certainly waste managers and consultants are certainly allowed to assist waste generators in meeting their legal compliance obligations, but the onus in law is now firmly placed on waste generators themselves. And again, there was a very key focus, and you can see it in some of the mechanisms in these regulations, where it's clear, to me, at least to my understanding and interpretation of these regulations, that there really is a drive by the regulator to promote the implementation of the waste management hierarchy. So if we look at the assessment of waste for landfill disposal, the regulations tell us that all waste generators must ensure that the waste destined for landfill are assessed and disposed of in terms of the landfill norms and standards. So there's two sets of norms and standards that sit behind or below the regulations themselves. And just to highlight that these are only relevant if a waste is going to be disposed of to landfill, whether treated or otherwise. Without having the time to go into the intricacies of each of those norms and standards, in essence, the first set of norms and standards dictates how we need to assess waste for landfill disposal. And it requires an assessment, so sampling and analysis and determination of the total and leachable concentrations of a predefined list of contaminants in the waste, which results are compared to a set of threshold values to determine a waste type. So that's either type 0, 1, 2, 3, or 4. Type 0, presenting an unacceptable risk to groundwater in the landfill scenario, requiring treatment prior to landfill disposal, and moving down to type 4, where these are fairly benign or borderline inert wastes with lower disposal requirements or landfill engineering. So again, it's that second set of norms and standards which then guide the actual landfill disposal. So they tell you, based on the waste type and other factors, to which landfill can I lawfully then dispose of this waste. And again, importantly, it is that second set of norms and standards that introduces the landfill prohibitions and restrictions, of which liquid waste to landfill is one that was brought into effect in August 2019. Again, I shan't labor on this too much. I spoke about the requirements to sample and assess waste to direct their landfill disposal. But what the regulator has done is they've basically given acknowledgement to the fact that certain waste streams are very obviously general wastes and certain wastes are very obviously hazardous wastes. So these waste types are identified under Annexure 1 to the regulations. And if your waste that you're generating falls definitively into any one of these, either general or hazardous waste pre-classified groupings, you don't need to necessarily formally sample and assess those streams for landfill in laboratory or whatever the case may be. That second set of landfill disposal norms and standards tells you or directs the disposal of these pre-classified wastes to the right landfill to which you would need to comply with. Just very briefly on the lab analysis, like I've mentioned, it's not generally required for pre-classified general or hazardous wastes to be formally assessed, sampled and assessed in a lab, unless you are otherwise trying to either confirm a physical parameter that might have bearing on the landfill disposal thereof, pH and moisture being typical examples. You might also want to assess a pre-classified waste in the lab to confirm some other compositional characteristic of the waste as part of best practice or based on client indications or empirical information that you have around that waste. Where we need to formally sample and assess a waste in a lab to determine the waste type, the regulations, again, they're quite flexible, I suppose is the word to use. You don't have to analyze for every possible contaminant that is listed in the regulations. It only needs you to analyze those contaminants which are either known, reasonably expected, or anticipated to occur in that waste stream. And I think that was an effort to not have waste generators incurring unnecessary cost in analyzing for pesticides or other organics, for example, in an inorganic stream that's known to be inorganic. And very importantly, that any lab analysis undertaken to inform the assessment for landfill disposal must be undertaken in a SANIS accredited laboratory. All right, so when we speak about the landfill disposal prohibitions themselves, restrictions, it's Section 5 of the National Norms and Standards for the Disposal of Waste to Landfill that direct those requirements. And I think the introduction of these prohibitions and restrictions to some extent was intended to drive the development of alternative technologies or solutions for those identified waste streams. So in some instances, based on the potential environmental impacts in managing those wastes to landfill and other practical considerations around managing those wastes to landfill, whether that's hazard or operating parameters that may be influenced, but certainly to, again, drive the implementation of the waste management hierarchy. So to start seeing wastes as resources instead of just putting them into a landfill. I'm going to show you a slide that I hope will just kind of round this view, but not all of these restrictions came into place on the 23rd of August 2013. Yes, some obvious restrictions came into place. For example, explosive, corrosive, flammable, or reactive wastes, as well as the likes of untreated healthcare risk waste. They were prohibited immediately from landfill disposal, but I think that was already largely the case as was enforced through landfill license conditions. But the remainder of the prohibitions and restrictions were brought in a phased manner. And I think that was to allow either waste generators themselves or waste management service providers enough time to ready themselves and implement solutions for landfill avoidance on those particular streams. And I think that the number of years granted in terms of how those prohibitions are phased in, I think speaks to some of the complexities around the differing waste types that are prohibited from landfill. And also, I think when something is in law and has the force of law, I think that gives a high level of certainty around anyone looking to potentially invest in appropriate landfill avoidance solutions. And I think we've seen that in industry, we've seen that in our customers themselves. There has been a real move to develop either on-site or other third-party solutions in the space. So this is the waste hierarchy that we're speaking about. And again, we could speak about this for an hour in itself, but ostensibly in principle, what the hierarchy advocates is that the landfill disposal of waste should be the last resort or least preferred alternative, with avoidance and minimization being the most preferred, and the pursuance of any treatment, recovery, recycling, or reuse options to be considered in between as necessary. And again, I think we see legislation and the development of waste management legislation really looking to drive the implementation of this hierarchy. All right, so if I have to bed down to a couple of the prohibitions or restrictions, with relevance to the audience that we have on hand today, I think we need to acknowledge that there are definitions that govern what is liquid waste and what is brown waste in the context of those prohibitions. So I think that's required in law to give certainty in terms of what we are speaking to. So when we speak about liquid wastes, and apologies, this is quite a mouthy definition, but we're looking at wastes that have an angle of repose of less than 5 degrees, or that become free-flowing at or below 60 degrees, or when transported, or that is not generally capable of being picked up with a spade or a shovel, or waste with a moisture content of more than 40%, or that liberates moisture under pressure in landfill conditions, and which has not been stabilized by treatment. So that's a lot to consider. One thing I would like to highlight here is, if we read into the last part of that part of the definition, it refers to and which has not been stabilized by treatment. I think that speaks to the fact that, yes, liquid waste can still go to landfill disposal, provided that the correct and appropriate treatment is effected in terms of stabilizing those to within the other parameters that you need to comply with. When we look at brine streams, we're talking about streams with a TDS of greater than 5%, as well as a leachable concentration for TDS of more than 100,000 milligrams per liter. So this is the figure that I was talking to previously, and it just aims to give a sense of how these prohibitions and restrictions have and continue to be implemented by the regulator in terms of the regulations. So in 2013, I think I've spoken a lot about that. There was a whole host of prohibitions that came into effect immediately. And then we've seen, as time goes on, the phased implementation of further prohibitions and restrictions as we proceed. And certainly, again, in the context of today's discussion, I think it was the liquid waste prohibition that came into effect on the 23rd of August 2019 that has relevance and bearing to this conversation, as well as potentially the prohibition on hazardous waste with a calorific value of more than 20 megajoules per kilogram. So August this year sees the further addition to this list of prohibited wastes. And again, in that context is brown waste or waste with a high salt content of more than 5% TDS. So these continue to be brought in, but just to make you aware, if you weren't, that the liquid waste prohibition is already in effect, and that came into effect in August 2019. Very briefly then, this is an empirical figure. It just aims to show how or what factors are driving innovation in the waste sector. So whether that's customers or waste generators themselves implementing solutions on their own sites, or development and implementation of solutions by the waste sector, as we see the disposal costs of landfill increasing and the pressures around available landfill airspace increasing, coupled with this increasingly robust legislation coming into play, what we're seeing in practice is certainly a host of additional development in alternatives to landfill disposal. So whether that's effluent treatment plants, we're seeing that at customer sites, we're seeing third-party effluent treatment plants being developed, we're seeing waste-derived blending, fuel blending platforms being developed, again, I think in direct response to some of these prohibitions. We're seeing refuse-derived fuel plants being developed and commissioned. We're seeing a renewed interest in anaerobic digestion, but certainly, legislation has a big part in driving that innovation. And again, I think when these prohibitions are there and stated clearly in law, investors or investment in these alternatives to landfill, becomes more tangible. Just from my side then, in closing, before I hand over to Nigel, again, to reiterate, we're seeing a continued development and investment in liquid waste treatment, recovery and recycling solutions within the waste sector. I think coupled with that is we're seeing increased interest in on-site solutions at customer sites, particularly around liquid waste management. And some of the tangible benefits around that is potential for recovery of industrial or potentially potable water in some instances. We do still see stabilization and treatment of liquid waste for landfill being required at this stage. But again, I think any treatment or stabilization of a liquid waste for landfill must give acknowledgement to the intent of the regulations, but also factors around the cost of treatment and stabilization for landfill disposal. So I think it will remain for the foreseeable future, but I think there really needs to be a bona fide attempt to pursue other alternatives before considering a landfill disposal solution, and increasingly so going forward. I think as landfill costs increase and the cost of treatment increase, we're going to see investment in alternatives really being driven and coming to the fore. Also important in this space is we will be seeing, to my mind, increased enforcement by our regulator. Again, we see that being reinforced in the National Waste Management Strategy that was just released. Hopefully going forward, we will see a reduced propensity for landfill leachate generation in the landfills across the country with the advent of this legislation. And again, there's a plethora of benefits out of that, anything from reducing, again, the potential for toxic leachate that needs to be contained and managed at cost. Also influences other factors such as landfill stability, hydraulic heads of pressure on landfill liners and their performance. So certainly, I think the legislation that we have in place is doing its part to drive the diversion of liquid waste from landfill. And I think it's for industry and the waste sector to really get on board and comply and make sure that we see this happening in practice as it should be and driving the waste hierarchy. So I thank you for your time from my side. Again, high-level overview, but I think if there are any questions, Corinne, please.
Okay, great. Thank you, Bradley. And I think you're really good at kind of giving us a very good high-level snapshot of where the legislation is at and kind of what's coming. And I think it's very good for people in industry to be educated around, you know, what this legislation means for industry. So thank you for that. So so far we have 2 questions, and guys, if you have any questions for Bradley, please pop them in the chat box. So Bradley, first question is from Nigel. He says, with the current trend in legislation, where do you see legislation moving in the next 10 to 15 years and beyond?
Sure, there's many moving parts to that question. You know, I think we really see the regulator translating policy into regulation to an extent, at least in the last 5 to 10 years, that we haven't seen previously. I think we have what we need at present to drive diversion from landfill, particularly around waste like liquid waste, brine streams, etc. I think that the enforcement by the regulator and awareness raising is going to play a bigger part in sort of 5 years than the introduction of any new legislation. That's not to say that new legislation is not coming. I think we're going to see new legislation develop, particularly around fiscal measures to drive appropriate waste management practices or incentivize appropriate waste management practices. And we're seeing that recently with the promulgation of the extended producer responsibility regulations. So not necessarily at this stage relevant to liquid wastes, but certainly we're seeing these fiscal measures being brought in to manage or incentivize priority waste, at least in terms of the regulator's view.
Okay, yeah. Bradley, Gerardo is asking what I think is a good question. He says, are there, or which guidelines give a definition of what the requirements are for stabilization of waste for disposal? And he says specifically for wastewater sludge.
I don't think there is a guideline document in place at this point in time. I think largely you need to look at the definition as well. So yes, again, it's a wordy definition, but first and foremost, I think is the assessment, is the stream more than 40%? There's various mechanisms in play at this point in time to demonstrate or to stabilize these wastes, whether that's ash blending, fly ash, cementitious agents, whatever the case may be. But I think we'll see that reflected in terms of less leachate being generated at landfill. There is talk, we're part of some technical reference groups looking at the waste classification and management regulations, and certainly this need for guideline, I can't speak for the regulator, but just in general, I think there's been an identified need to develop guidelines exactly around issues like this, issues around sampling, how that's undertaken. So hopefully we see these coming into play. But I mean, again, I can't speak for the regulator or give any sort of commitment around that.
Okay. And then I think we'll take one final question before we move on to Nigel. Jason asks, are you aware of the legislation being enforced and what the legal enforcement and penalties are? So has there been kind of an increase in enforcement, and what kind of penalties do you see happening?
Well, I mean, I can only speak to the penalties in terms of the Act and regulation. I think that's 10 million rand and or 10 years imprisonment. I don't know of any precedent around the regulator enforcing or any compliance related issues for specific customers or specific waste streams. Certainly none on our side as well from an operational waste management service provider perspective. But I think it will come. I think it really will come. I think perhaps the regulator is giving people a chance to understand and implement, but to an extent that ship has sailed. I mean, we are nearly 18 months down the line since this has been in play. But I mean, as a landfill operator, you would need to demonstrate and have the backup documents and analysis and whatever the case may be to show that you're not putting liquid wastes to landfill at the very least.
Okay. And obviously, and I think Nigel will touch on this a little bit, there's obviously, we wouldn't call it a penalty per se, but there's a cost implication for industry specifically when sending waste for disposal that now requires additional treatment before landfill. And it's that cost that you can almost see as a penalty for industry as well.
Certainly, and I think, I spoke about these fiscal measures. We obviously had the National Waste Management Pricing Strategy document has been out for a while. There is a chance going forward that we may see landfill disposal taxes coming into play as well. So again, but we're not quite sure how that would work, whether it's going to be volume based or what the case may be. But certainly, when that starts coming into play and you look at the treatment costs involved, it might make the business case for on-site solutions, whether that's dewatering or treatment or whatever the case may be.
Okay, great. I think, thank you very much, Bradley. And if you guys have if we come to the end and we have a little bit extra time and you have more questions for Bradley, please put them in the chat box. Otherwise, I will also pass questions on to Bradley and he can answer it via email afterwards. Okay, so I'll hand over to Nigel now. Thanks, Bradley.
Good afternoon, Kieran, and good afternoon to everyone. And thank you, Bradley. Always fantastic to hear you speak. I learn more every time. So thanks to you too, and thanks to Kieran for hosting this from ZebraTube and for taking the initiative to, I think, shed some light and bring some focus on an incredibly important topic. So I think the next few years for us, specifically South Africa, will hold a critical time in managing and implementing wastewater and water recovery, reuse, recycling, reduce our demand on the national grid, free up potable water and more. So that was a fantastic opportunity which we jumped at to be a part of. I have noted I've got a few comments there for Gerardo and Jason Holder later on, but I think we'll touch on those at the end. To kick off, this is a very high level on our water OEMs and suppliers. It's a high level. I think everyone knows you could sit on this, as Bradley mentioned, on some of his topics for an hour a week or a month on one of these slides. There's a lot of depth, so we're looking at a high level. The goal of this part of the presentation is more to share the hierarchy of waste management and the cost of waste management. I, for many years, worked as a water treatment OEM and saw things from a specific perspective. I now have a marginally broader understanding and I would say a more holistic approach, still not at the level of Bradley, who's been in the industry a decade longer than I have. But it's quite eye-opening when you realize that the costs that you're trying to manage are sometimes not where you're looking. So we'd like to bring some more insight onto that and to maybe share that holistic approach as best as we can. And then we'll just be touching on some of the different technologies you could be looking at. And specifically to Gerardo, who asked the question there with regards to wastewater sludge management, I think by the end of this, you may have an idea and a philosophy of the way forward from the beginning of the process to the end. And I think that's the goal of this. So we're going to start off with a brief overview of the true cost of waste management. After that, we're going to go into a couple of the different technologies available, and we'll close with a few case studies just to give a brief understanding of the implementation. So the true cost is enormous, for lack of a better word, and it is not as water, wastewater. I see we've got OEMs in the room, end users, suppliers, and obviously some waste managers as well. It is not always where you think it is, and this was quite alarming for me to realize this. So we were often trying to optimize the wrong parameters. So it's about focusing on what matters most in terms of costs to your clients and holistic cost. Analysis and classification is something Bradley touched on. It's where it all starts. So if you've got a waste that needs to go somewhere, first things first is you need to actually analyze and classify it according to the waste regulations. After that, if we're on site, we need labor and equipment, and we need to get it onto a truck. We need to move it somewhere. It's unlikely you're going to have pipelines set up for this unless you're a very large generator. After that, we'd potentially at a landfill site. Hopefully we don't go there. We go to a reuse or a recovery facility. We would move to handling, blending, and preparation, where we use a ratio of either, as Bradley mentioned, ash, fly ash. We could blend different streams together. We have to manage various parameters according to your analysis and classification of the waste to allow it to go into certain landfills. which obviously we're trying to avoid, but this is the end of the line. The treatment and disposal into landfill airspace consumption is also enormous. I've got a brief picture there in the top right to just give you an idea of what goes into landfills, but it's a specific area. It has to be stabilized land. It has multiple layers of soil compaction, different types of soil that you have to put underneath. We have multiple liners, typically 2 or 3 mil HDPE liners, usually double lined with hydraulic sensing. It is not a cheap activity. It can cost north of 80 million rand for a relatively small landfill to be set up to accept as landfill. You've got to manage the leachate generated from that. At the end of life, you'll need to cap the landfill and close it off to prevent water ingress and continued leaching of the contaminants. And at that point, you still need to continue to manage the rainfall that lands on the area and measure, monitor, and safely dispose of that. Compliance monitoring is what we're describing there around that. And obviously, this doesn't happen on its own. You need a large management team. So it is not a small environment. There's a large number of different costs that come into it. And it's the reason why we want to look at dewatering and reducing certain of these costs. Some typical challenging parameters that we come across with clients that approach us for solutions is if you've got low volumes of certain wastes, it's not typically cost effective to do on-site treatment, and you'd look for more of an integrated approach, transport, treat off-site in a centralized facility. Typical parameters that flag that can't be treated or at least discarded or disposed of on-site will be high TDS, so your dissolved solids once you go beyond municipal sewer discharge standards. These do vary. They're different from domestic. You'll need special licensing, but typically 5,000 microsiemens per centimeter on your TDS and 5,000 ppm. Beyond that, we need to treat it at one point or another. Oily wastes, potentially even solid contaminated, are also a large challenge that we find. Large volumes in industry that need to be treated. Varying contaminants. We often have complex waste streams resulting from different industries. And when I say complex wastes, they're not necessarily just contaminated with a organic or an inorganic. It might be a complex combination of organic and inorganic, cyanide, various heavy metals, and more. And acid waste streams are also very common from industry. So the sector we're moving more into in terms of hydrochloric and sulfuric acid, polishing, cleaning, reuse, reconcentrating, or even potentially transferring to other clients that could use lower concentration acid. So some of the brief drivers. South Africa's water scarce. This is well known. I've got a lovely picture there of one of our dams a year ago, what it looked like. It was quite a frightening time to live through. We had near day zero on multiple cities. There have been targets set by local municipalities, specifically in the region of 15% reduction, specifically prevalent in the Gauteng area. And those reduced targets are non-negotiable, and they are subject to heavy penalties if they do not comply in the coming years. Obviously, the prohibition of liquids and brines to landfill in a move to continue to improve our use and reuse of water. More stringent use on calorific value. So instead of throwing something in a landfill, it actually has value. So extract that value in terms of energy. We're also seeing a number of clients that when they reapply for water use license or their operating licenses, they're receiving more stringent operating conditions and they can't continue to operate the way they did. So, you know, we can't continue just as we have before. Things do change and things have become more stringent. So clients come for cleanups of certain waste streams and they need to run capital projects on their new legislation. And this is the legislature moving to implement more stringent and more environmentally aware legislation. And it is being implemented, I can guarantee you that. I'll touch on some of the penalties that I know about that have been handed out at the end of this. Reduced footprint globally. So big push. A lot of multinationals we work with are, they've got metrics. So just for the food and beverage industry, for instance, on a water use, they look at kilograms in or liters in per liters out. And that's a metric. How much are we converting of our usage to usable product? And that's driven extensively. It's on some key KPIs that they run. And it's about reducing our total footprint in the production process. And obviously, the last one, the increased transport, labor, and water costs. As costs go up, it starts becoming more and more feasible for us to actually do run projects, capital projects, and reuse, recycle locally. So there's a Those are a few, but very significant and things that we've seen having traction in the last few years. So just some basics. So maybe out of place in this, but I've been a part of this on client sites where we start with step one, reduce. So say the water treatment is it's complex and there's no silver bullet, there's no one treatment technology that solves everything. But if you have to reuse, do the easy stuff first. And this might not be complex, it might not be my field, it's definitely not water treatment, but it is the easiest thing to implement. So look at implementing high efficiency showers. They cost you very little and they save you a lot. Look at cheaper and air injection on your taps. Look at monitoring so the taps auto start on and shut off. You would have seen this at all of our airports around the country. They're moving to these smart systems. Pressure control and pressure regulation systems on your potable feed lines. The grid fluctuates from anything from, well, when there's no water, nothing, but typically 2 or 3 bar pressure and possibly as high as 10 bar. So when someone uses a system, if that pressure isn't regulated and modulated, you could have large flow rate variance downstream. So put in pressure regulating systems. And lastly, a very simple one to do. Many clients we deal with, they don't know where their water is used. They don't know which parts of their plant use it. They don't know if they have leaks. So just put in cheap and simple water monitoring, usage, and measuring systems. So it's a simple way to go to get your biggest benefit. And that's a long-lasting one to implement. So just a point of departure on reduce. There are many technology options. So if you have issues with high biological or BOD, COD, potentially even ammonia, phosphates, nitrates, and anything else that we can biologically degrade, we've got some options. If we have decent volumes, we could potentially look at an on-site treatment option. Anaerobic versus aerobic. Typically for our higher COD loads, it's more expensive, but there are a lot of benefits to running anaerobic digestion. We have biogas generation, and that gives us the option to reuse the methane that's generated from that. It also produces a significantly lower sludge volume than aerobic system, as a lot of the degradation of the hydrocarbons or your complex molecules comes out as methane, which you can potentially use as a fuel for a boiler or otherwise. Depending on our discharge criterion, you might need to move to aerobic polishing, or you might just use aerobic for your main processing. Many technologies, it's been around for a long time, but there's continued innovation in the space. So MBBR and MBR are maybe 2 initial options, a small footprint and very effective. That's a moving bed bioreactor. I've got a picture there in the top right of the carriers that actually hold and carry the biomass. Membrane bioreactor, I've just got a picture there, dead center at the bottom of the filaments. So that's an integrated biological film reactor, or membrane bioreactor rather, with an integrated ultrafiltration. So integral to the process is really the biological reduction of your BOD, COD, potentially ammonia and nitrates, depending on how you design it. And you're also then passing it through effectively an ultrafiltration system, which filters out all your microorganisms. Trickling filters, well known, very simple, very robust, great solutions for small to medium plants up to about 0.5 meg a day. Activated sludge, extensively used throughout the world and in South Africa. Sequencing bioreactors, and the list goes on. There's a number of solutions if your problem is BOD or COD. So a few things to consider if that's your challenge. High TDS water, so total dissolved solids or salinity. Some of our biggest challenges come from these spaces. Once you go past the municipal sewer discharge limits, you're really kind of in an endless loop. You're going to end up with a brine that needs disposal. But there is a lot of innovation in the space that can assist you with this. So just touching on some of the membrane technology that's been emerging in the last few years, just selected a small screen from Hydronautics. But if you go to any of the global OEMs, they're all experimenting, exploring, and developing new membrane technology that allows for improved reuse. So if you look at what used to exist as a typical reverse osmosis membrane, you now have ultra high pressure membranes, high pressure membranes. We've got differentiated nanofiltration membranes, which just selectively remove divalents. So interesting case study is potentially in the textile waste industry, where we could use a initial filtration. You could run a nanofiltration membrane and then separate out your sodium sulfate, reconcentrate that with an evaporator, and run into a reuse process quite simply now, because you've got specialized, basically a molecular sieve It's allowing divalents to pass through and your monovalents to move on. With ultra high pressure membranes, you can now also take that brine up to a much higher level where we can recover and reuse more water. Electric coagulation as the next option is very, very different technology, but it's having metallic electrodes passing current through your water and selectively precipitating out some of the dissolved solids. So if you need to polish your water or reduce some of the dissolved solids, it's an interesting option and can present as an option to prepare the water or reduce the total dissolved solids. It's not going to get down to a zero level, but it is useful. Chemical precipitation has been well used for decades, either lifting and dropping the pH or targeting specific precipitation reactions. Calcium sulfate precipitation reactions are very well known in the mining sector. Just for example, after we get that, we have thermal evaporation. Got a picture there in the bottom right. This is relatively quite expensive, and depending on the technology, we can attain different levels of TDS, or total dissolved solids, as high as 30% on a mechanical vapor recompression system. I've got a picture there at the bottom of a flash contact tank. You can potentially go as high as 60% total dissolved solids if you've got scraper versions. So there's various options, various CapEx, OpEx trade-offs. And forced evaporation is also an interesting one. I've got a picture there, dead center at the bottom. You have a very large area. You could also run an evaporation pond where you take this and for 10 to 20% the CapEx and OpEx cost of a thermal evaporation solution, you could evaporate on an open pond, let the solids dry out. So it's really turbocharging what someone like a salt mine would do, a Cerebos or equivalent, where they put things out in the open, evaporate, and the solids stay behind. We're just turbocharging that by atomizing through the air, but you need space. So some other technologies, if we run into oily waters that we need to treat, challenging to push through any kind of a membrane process or a filter press. We'll come to those in a second. So typically we run a oil water separator is your cheapest, just to run gravity separation on the density. Dissolved air flotation, bottom right, there's a picture where we, if you have low levels of concentration of oil, so maybe 1%, we could take out 90 to 99% of the oils in emulsion with a combination of demulsifiers, coagulants, and flocculants. Please bear in mind, almost all of these technologies always run back to back with modern chemicals, and the whole chemical industry, I haven't touched on this, is also very dynamic and moving quite quickly to support each of these processes. Centrifugation is a very, very widely used in this. It effectively, through centrifugal force, turbocharges the natural gravity separation. So if you have a density difference in between solids and your liquid phase of oil and water, you're just basically turbocharging that effect of the density variation in the substrate. So for the solution, decanter or tricanter, a decanter would just be taking out your solids and leaving all your liquids together. And if you had solids combined with oil and water, you could potentially then take out all three streams as separate in one process step. High-speed separator is just basically the next step of turbocharging centrifugal force and much lower solid load ability, typically under 1% solids, but very good in polishing out and removing solids from a water and solid stream. So I suppose the last one, and maybe the focus of this presentation, we should have gone to this first, is the dewatering and thickeners. And this really is, if we go back to the first slide, focusing on the total cost of transport and associated transport, processing, handling, and preparation for landfill if we have to go there. So to dewater on site has multiple benefits after that in terms of cost reduction, in terms of the handling and the processing of your waste stream. So again, if you have a solid contaminated waste stream, a decanter or a tricanter is very effective at taking out solids. Could be as high as 40 to 60% dryness, which is a very good number. High-speed separator, as mentioned again. Belt press, well used, well known for taking out any solids that typically doesn't have high fats, oils, and grease content. So well used on sewage plants to dewater, and again, we can attain as high as 45% dryness on those. A multitude of operations. Screw press, it's the center at the top. We often use on more oily waste streams, pulp and paper industry and others, where we need to compress and dewater a variable waste or an oily waste. So it's very robust, and also will give you a dryness beyond 40%. Our clarifier thickener, I just included there at the dead center at the bottom. This is often more large municipal. So moving from a primary clarifier to a secondary thickener before we go to dewatering. And this is all about CapEx, OpEx balance, and it's more specialization of our professional water OEMs. But it tends to pay itself off because you can downsize the size of your following dewatering stage. So it has a place to play. It's a CapEx, OpEx balance that you need to run. Plate press, also top there, middle on the right, is similar to the filter press. It's just different. We can run very high pressure on the filtering, but the same constraints remain that oily substances are not always easily dewatered, as you do have a filtering mechanism. You can overcome this with the addition of certain chemicals, and we've successfully dewatered some very heavy oily waste through that. But it does require addition of a lot of chemicals to allow the water to percolate and move through the substrate. Gravity drainage solutions, I suppose the focus of this presentation, essentially dead center at the bottom there. It is definitely your lowest CapEx solution to get good dewatering. And we'll touch on a case study in a moment on that, where you can pass your solids through, potentially add a coagulant and a flocculant to improve the size of the flocks and improve the rejection and the retention of the solids. If you have slightly oily substances, you can also do chemical ejection and addition to allow for dewatering with light oil solutions. Of course, you have to pay due consideration for oil-containing waste so that you don't end up covering the bag and preventing the water from dewatering. So I think to close, we're going to just touch on two brief case studies. Apologies for the light information, but we do need to respect our clients' confidentiality. So they will be very high level, but I think just to give you the insight or the idea of effectively what goes into dewatering and saving costs. So there we've got on the top left there a client's concern. So what we're looking at is a solids buildup in a tank. This is not glamorous, it's not exciting, it's not high tech, but it was costing the client a lot of money, and they were spending a lot more than they needed to, and there was an easy solution. Easy for someone that's in the field, not easy for the client because they don't understand water management and waste management. So what was happening is they had a reservoir, a storage tank that boosted over to their main raw water storage, which was an aeration, partial biological treatment tank, and they had extensive solids buildup. And we were doing batch cleanups every 3 to 4 months, and they were out of production then for 3 to 4 days at a time. When we were pumping out these liquidy solids, it was low solid content, so we end up tracking water with the solids. When you get to disposal, you've got a lot of water to process, a lot of blending material. You then bulk up that solids and you have a lot of landfill airspace. So it's really a ripple effect all the way down the line. So dewatering on site isn't just the basically reduced management of waste, reduced transport, but it is exponentially in terms of the reduction of landfill airspace consumption. So they had lost production, they had these bulk cleanups, increased chemical consumption because they had all these competing reactions from the solids that were passing through downstream to the next processes where they were chemical precipitating various components. And obviously equipment blockage and fouling because of all these solids moving through the system. So the solution was relatively simple. Do a stock standard lamellar clarifier, put in some coagulant, flocculant, and do an inline removal of their solids. And then to improve our overall cost model, take the dewatering through a dewatering bag from someone like ZebraTube. Benefits were enormous. It was a low capex project, but increased production of over 9 days per annum. A 2.5% increase in production is enormous when you look at your net profitability over a year. Big reduction in the cost for the batch cleanup because our solids were much higher. So we went from a 5 or 6 or 8% solids with liquid pumping to about a 30% solid. It's a significant reduction in our transport. Their chemical consumption reduced because they had less solids moving to the next process and reduced maintenance. I didn't even mention here the reduced cost with processing and treatment to landfill disposal. So multitude of benefits for implementing an old technology with some novel other solutions. And we've got a second case study here. that covers and solids buildup in a waste dam. So this is a complex waste of oil, water, and solids from multiple sources. And the client was running into a problem where what we spoke about previously, the existing license doesn't allow them to continue disposing the way they previously did. They need to look for novel solutions. And obviously, with the dams filling up, the license not allowing it anymore, there was a potential to have a reverse cascade of and a shutdown of their processing plant. So if they didn't do that, they also had the risk of potentially overflowing their dams and polluting the local environment. So it was urgent that we found a solution. It was a solids content of, again, about 8 to 10%, oil content of 8 to 10%. And what we looked at is to put an on-site dewatering system. There's a brief picture there on the right of a typical setup that's done. And it involves effectively a pre-homogenization tank, coagulation, demulsification, heating to about 70 to 80 degrees, depending on where you find the best separation, and running it through a tricanter centrifuge. And that took our solids from 8 to 9% all the way up to about 45%. So very, very large, significant reduction in the transport volumes and the transport mass, and again, the associated landfill airspace consumption. Further to that, bioremediation also became an option, which stops us having to put it into landfill, and then we can look for other solutions like landfill cover. So again, not particularly innovative in terms of the technology. It's existing technology, but it's applying it to a specific case. And thank you very much for your time and attendance. If there are any questions, I'll be happy to take them.
Okay, great. Thank you very much, Nigel. Very informative. Is there any further questions for Nigel at this stage? I know, Nigel, you said you wanted to address some of the earlier questions as well.
Maybe I can start there if no one wants to talk to me. That's perfect. So Gerardo, just there was a question around waste management, and maybe come back to Bradley. But effectively, you know, we can't give you an answer, but we can give you the formula. So, you know, step one, as Bradley mentioned, we need to classify it. So it needs to run for analysis in terms of the full spectrum of chemicals, both organic and inorganic. We need a moisture analysis of where we are. And from there, we can start determining, you know, and obviously volumes as well play a point. Does it make sense to look for on-site treatment and dewatering? Do you do something with a low capex, such as a ZebraTube? Do you want to go more industrial with centrifugation or others? And then depending on the classification and the volume, you know, you've got to build the solution fit for purpose. But it all starts with classifying the waste, both volume and the chemical concentration of the various contaminants. To Jason Holder, there was a question there around, are they actually implementing penalties? I can just mention, no names obviously, but I've probably 7 years ago already, a local municipality was implementing over 300,000 Rand a month in penalties for a user that was discharging 80 cube a day. And it was they were over the local limit on, it was COD and FOGs. Bradley can probably weigh in a bit better with the overview, but it's very important to understand our waterways are managed and checked by, I think it's the Green Scorpion still, unless something has changed, but local discharge and local compliance is run by the local municipality. So there's kind of, and then often our domestic effluent, if I can call it domestic effluent, they often end up treating some industrial effluent. The sewage treatment plants sit at the interface between these two, and it can be a very difficult space for them to operate because they might be non-compliant downstream and receiving penalties and fines, but they're receiving effluent that's off-spec because the local municipality isn't doing their job. I personally know the municipality of the certain areas that are very happy to go and do their job because they get to issue these fines and have extra revenue. So they're incentivized to actually, you know, do their job and enforce compliance. And I know of several cases that have actually pushed clients to implement very good technical solutions and to become compliant because it was actually more cost effective to implement a solution than to continue to pay the fines. So maybe Bradley can weigh in, but that also weighs towards the fact that the fines are fair and appropriate to drive the corrective action.
Is there any other questions for Nigel? I don't see any specific ones relating to his presentation at the moment. So yeah, I think what I'll do is I'm going to do a 3-minute presentation on ZebraTube, specifically relating to this sector. And then if you still have any further questions for either Bradley or Nigel, please pop them in the chat box and we can do a final Q&A before we finish off. I know we're running a little bit over time, but it seems that everyone is quite happy to stay on. So I'll quickly do that. And then, yeah, any further questions, just pop them in the chat box. Okay, so first of all, I guess I should just reiterate how thankful I am that everyone joined today, and also to our speakers for creating such good context regarding liquid waste and landfill and the absolute need for treatment, reduction of waste, and reuse on site, and then obviously dewatering in order to avoid massive penalties going forward. So just quickly on ZebraTube. For those of you who were in the webinar early on, you would have seen the video that shows the different options that we offer in terms of geotextile dewatering. But specifically, we have essentially 2 configurations, either the smaller scale option, which is what you see on the left, which is a small scale bag manufactured from this geotextile that has a specific filtration and permeability characteristic, which allows it then to dewater solids to a specific moisture content whilst you can then obviously capture the filtrate. So for these small scale applications that we see quite often in the waste disposal or waste management sector specifically, we often see use of the small scale bags specifically because they are so easy to handle. So they come with these forklift handles, which means that you can transport the dried material or dewatered material in the bag itself, and it just makes handling of the waste so much easier. And then just to mention on the right, and you would have seen this in the video as well, we do have the larger tubular configuration, which is where the name ZebraTube essentially comes from, which is the bags that we manufacture in a tubular configuration from the same geotextile, and which then allows you to dewater and contain the material inside this tube, whilst obviously capturing filtrate. And these larger tubular configurations is typically what you would use on very large dewatering requirements, and is what we would sometimes use on large volumes of sludge that needs to be dredged from a pond, for example, or a dam at a wastewater treatment works, or at an industrial site where they need capacity increased in their dams, and then the solids contained in that dam can be dredged and pumped into these large tubes in order to contain the solids and dewater it, so that an excavator can then come in and remove that material so much easier because it is then dry enough. So that just gives you a brief idea of the 2 different main configurations that we have. And then just quickly to mention specifically on the small scale square bags, which is very relevant to this context, we have various different configurations. So for example, we have an open top, which is very commonly used in this industry. And then we also have a top panel with a funnel in it, which then allows you to strap your piping into this funnel, and then you have more of a closed top configuration. We also do a bottom discharge, which we also see used quite often in this sector, specifically because it allows for discharge of the material from the bag. And then just a duffel top, which is more used in mining, but just to allow you to close off the bag after you've contained the material. Just to quickly mention, we also have some auxiliary products, such as a support frame that we manufacture for the bags itself, so that the bag can be supported. So the bag basically is hooked in the corners, and your bag sits on this drip plate, which has grating on top of it, and your filtrate then collects in this drip plate or drip tray, with a drain that then allows you to obviously channel your filtrate back to the process or for reuse, so that you don't actually have filtrate losses. So that is literally in a quick little nutshell, ZebraTube specifically in this context. Is there any further questions? Let me quickly check the chat box. Doesn't look like it. Okay, so thank you everyone for your time. Thank you for taking the time out on a Friday to listen to us and to engage with us today. I have all your email addresses. I'll be sending out the recordings. Similarly, if you have any further questions, please feel free to contact me. I'll just quickly put my email address in the chat box as well. If you have any further questions, or for Bradley or Nigel or myself, please feel free to do that. And then just have a great Friday. Thanks, guys. I'll just stay on a little bit to see if there's anyone else who wants to still pop their email in the chat box. And then I'll be sending through the recording. Thank you very much.
Thanks, Corinne, for organizing and managing. Much appreciated.
Pleasure.
Yes, thanks for the opportunity.